been able to hear you the whole time, but I guess everybody else has not. So
Okay.
I do see where they believe they have the audio corrected. So if you don't mind, can we
Oh,
start
sure.
again with what is sanitation and how does it differ from cleaning?
So, yeah. And, what we talked about here is that cleaning and sanitizing are two different processes. That if we don't first clean, if we don't remove that dirt and soil that can harbor bacteria, then, we're not going to be able to sanitize and kill the viruses, the bacteria, the yeast, or the mold, or the algae that can impart either off taste or odor or an outright contamination of the ice. You got to remember, ice is food. So everything that we do here is the same thing that we would do in any food manufacturing plant. Constant cleaning, constant sanitizing. Then I talked about that, again, cleaning is separate. I don't care how much bleach or quats you pour on a surface, it will not clean it. When we talk about cleaning, we're talking about separating the dirt and the soil from the surface. So it's got to be something that enables that dirt to lift off. And we call them surfactants or soaps or degreasers. All of those are effective. Once you've got the clean surface, you're down to that machine. Then when you pour the sanitizers on, you're actually killing the bacteria forever. Otherwise, you leave behind a biofilm, and while you might kill the top surface of the biofilm, the bacteria and viruses underneath will simply begin to multiply the next day. We talked about the idea that there are three areas to focus on. First and foremost is our employees. It's not intentional, but I believe probably 80% of our sanitation issues originate from employees. They're not properly washing their hands, they're not wearing gloves, they're not taking the care and attention that's necessary. Then we've got the ingredients, and pretty simple. We have one ingredient, 99.99%, and that's water. So we want to make sure that that doesn't bring contamination in with it. And then we talked about the production process. And, there's a lot of different aspects. There's the ice machines themselves. There are the augers and conveyors. There are the different kinds of shakers and sizers. All of these have the potential to harbor bacteria. So they need to be cleaned and then sanitized on a regular basis. Ultimately, our delivery vehicles, where we put that ice before we put it in the freezer boxes, also has to be kept clean and sanitized. If these aren't all pulling in the same direction, then we're going to end up with contamination that we don't want.
All right, terrific. So let's dive into a little more detail, starting with our water, our incoming water. What do I have to be concerned with, especially if I'm using water provided by a city source? And if I do have to be concerned about it, how can I sanitize it to eliminate the bacteria, viruses, and other items?
Great question. And the challenge that I would put to everybody listening today is, do you know the supplier of your water as well as you know your bag supplier? Because this is 99% of your ingredients. And if you're not on a first name basis with the person managing the water plant, then you're not going to get all the information you need to be aware of the quality of your water. You need to know where it originates from. How does it get to your plant? What types of disinfection are used by the system? What kind of hydrant flushing programs do they have? All of this leads you then to be able to build a strategy to control scaling, which can cause problems not only in ice making, but also places to harbor bacteria, and then ultimately the safety of your treatment. And not every plant is going to have the same solution. You've got to tailor it to what you've got to deal with. So this takes us to the idea that if you're using a well water source, you're on your own. There's no big company behind you. There's no public utility looking at this day and night. So you probably need to exercise an extra layer of caution. If it's a public water system, you want to know how much disinfectant comes in with that water by the time it reaches your plant. We've talked in training classes about measuring something called the free chlorine. This just says how much chlorine is left to kill bacteria and viruses before you get a hold of it in your plant. These are things that are very easy to learn about, very inexpensive to learn about. And from that drives a strategy on how you treat the water. So you may need a sediment filter, you may need a carbon filter, you might want to do water softening or even an RO. But don't do any of those until you understand the quality of the water and what you're trying to protect against. Lastly, we talk about water disinfection. And again, we have to go back to the origins of this. Is it a well water? Is it a public water system? How much chlorine is really effective to be there? But you may choose to use an ultraviolet as a measure of protection. And here I caution you on a couple of things. Make sure that that UV is scaled to your water system. A lot of these UV devices might have been put in when you first built your ice plants. In the meantime, you've added ice capacity, but maybe you haven't scaled up the UV to keep up with it. So talking to your provider on that's really critically important. There's increasing interest in using tools like ozone, which leaves a residual in that water to disinfect it. And we'll talk a little bit more when we get into the emerging technologies on that.
Terrific. All right. Well, thank you for that focus on our incoming water. Now let's talk about, I guess, a little bit what needs to be done with our equipment, our ice makers, our bins and baggers to properly sanitize them.
Great question. And it's clean, sanitize, endlessly, always. Our goal is to keep any kind of rust or scale or biofilm off of our equipment that could possibly be harboring the bacteria or the viruses. If we can do that, then we're going to have nice, clean ice. But if we leave cracks and crevices untouched, or we have areas that get very warm or very humid, then we have a real danger of incubating bacteria and viruses. Remember that if it's above 41 degrees, you're going to get bacteria growth, regardless. So the warmer it is, the worse your issues are going to be on containing the bacteria and the viruses. It's an interesting situation. We did a survey of IPIA members a couple of years ago, and we were very surprised to discover that while there were a few ice companies that were bagging inside of freezers, so obviously it was below freezing, the average temperature in bagging rooms ranged between 50 and 70 degrees. 70 degrees is pretty warm, but you can imagine how that happens in the summertime when you're opening up to a loading dock and you've got a lot of air going back and forth with forklifts and moving product. And I can guarantee you at 70 degrees, bacteria is going to grow in that bagging room. It's going to grow in the ice machines because it's just so warm and humid. So you always have to be very diligent and try to control your environment as much as possible. And then you've got to pick the right solutions. Remember that clots and bleach don't clean. You need some kind of surfactant, a soap, a degreaser, something to help lift the dirt off of the surfaces. And then you come back in and you kill the bacteria that's visible with the clots or the chlorine or iodine-based sanitizers. A two-step process, two different chemicals done at two different times. And then you've got to do every area around the plant where this bacteria could harbor. And that means the bagging room first and foremost, but any augers that are in warm areas, even in rake rooms, got to make sure that there's no air leaks coming in there that can create areas of contamination.
All right, terrific.
I think one other thing, and this may have been where we transitioned with the audio, but just remembering that cleaning can use a lot of different chemicals, and make sure that you're using them accurately. So if you've got procedures that say, I'm going to use 200 parts of chlorine, make sure that you're taking the time to use that test strip so that the chemical is doing what it's supposed to do. And in a lot of places where you get a little bit of eye judgment and maybe there's enough left in the container to get you through another day, you can't do that. You need to mix cleaning and sanitizing solutions and then do something to make sure that you're using the right dosage every time.
Terrific. So is it something different than I need to do when I have to worry about the rest of my facility outside of the equipment for, sanitizing buildings and offices, floor drains? I know it can be a big concern, route trucks and those kind of areas.
Yeah, it's all of the above. In terms of the facility where you're making ice, where you're bagging ice, where you're storing ice, it's the walls, floors, and ceilings. It's making sure that there's nothing there that can give a safe harbor or a hiding place for that bacteria or mold or yeast or anything else. In the offices, what we're really concerned about is the bacteria and other things being brought back and forth by employees. We're not expecting that the office be the same cleanliness standard as a food production area, but you do need to make sure that people who are going back and forth are not bringing contamination with them. Then you mentioned very accurately floor drains. Making sure your facility is set up so that you can actually clean those drains. You know, oftentimes I've seen equipment placed on top of a drain and there's no way to actually access it. So make sure that you can do that in your facility, because things like listeria love that cold, dark, humid environment that a drain provides. And then last but certainly not least is the route truck. And as we've learned in the world of COVID, it means the cab. It means keeping that clean so the driver doesn't pick up contamination. And then the back where the ice is kept, and ultimately the ice freezers that we put on customers' locations. All of those have to be looked at and programs developed to keep them clean and safe.
Terrific. So I think you said one of the most critical areas that we need to focus on are our employees. And if that's the case, how can employees contaminate ice, Chris? And then if so, what kind of preventive measures are available to help minimize or eliminate that potential contamination?
Excellent question. And I come back, you ask anybody, you know, what I'm fixated on, and they'll tell you it's hand washing. I think 80% of the issues of contamination that we have in an ice plant come right back to employees not having the opportunity to do proper hand washing. And I always ask the question, you know, is it possible to go from the restroom facilities to your bagging room without recontaminating your hands? You know, are the faucets you use hands-free? Is the soap hands-free? Are the paper towels single-use? Are the trash cans foot-operated? Can you get in and out of doors without having to touch that handle and recontaminate? So that's a basic place to start. And if you can do that, I think you're 80% of the way there. The photo shows kind of a model hand washing station. It's also, you know, the place where you can keep the face mask and gloves and the other safety equipment that needs to go into a plant. The other areas that you know, have become far more important than I frankly ever would have thought is what COVID has taught us about the use of masks and gloves and even shoe mats, where we can sanitize people's shoes going back and forth from a clean environment to a dirty environment. I think everybody has gotten a huge education on the value of these tools, and I think they're going to be with us on a long-term permanent basis just to improve the overall cleanliness and sanitation of our facilities.
Terrific. Thank you for that. I guess next, is there any new technology, Chris, that really isn't all that prevalent in the packaged ice industry at this point that can be used for sanitation processes?
There certainly is. And again, this was happening before COVID. I think you've probably seen, I've written, I think now 2 articles in Ice World Journal talking about something called ozone. And this is just electrified oxygen that operates as an oxidizer and kills any type of yeast, mold, bacteria, viruses, algae on contact. It can be used to wash down the facilities, the walls and floors. You see here an image of a cart. You can hook it up to a water hose and it'll infuse that water with ozone, and then every surface that you have cleaned and sanitized gets a nice residual coating of ozonated water. The nice thing is when you flush that water down the drain, you're cleaning the drains as well, because ozone will kill listeria on contact. Some benefits to this system is that it's residual free. In a matter of a few hours, there's no ozone left. And certainly the next morning, it's all gone. You generate it on site, and you don't have to worry about any chemical disposal because it goes away and is considered to be safe by all of the public utilities. The other thing is it really has no impact on the taste. And I call out, there's a Canadian ice company that has been using ozone in their ice water and their cleaning for over 20 years. And if you'll ask them, their HPC counts are as close to 0 as anybody gets to. So that's one exciting technology. Another one is something I have to admit I really didn't know much about at all until COVID. And you've probably seen these commercials from Delta Airlines sanitizing their planes, or maybe you've contracted with janitorial service to come in and deep clean your office and wonder, how do they do this? And they use a technology called electrostatic cleaning, where they take a disinfectant, and I stop here to say, make sure it's an approved disinfection from the EPA list. It's published online of substances known to kill COVID, turns them into very, very small droplets and electrifies them. And when they come out of the sprayer, there's a magnetic attraction to the surfaces of your equipment, floors, chairs, rugs, everything. And it creates an adhesion. And then as that disinfectant dries and evaporates, it kills everything in its way. The further advantages is that you get a lot higher yield on disinfectants because the mist is very small, bubbles, but it's very efficient. So you don't waste a lot of the spray that you normally do. This month's Ice World Journal has an article to give you more information on it. Then the other thing is, necessity is the mother of invention, and I've been very impressed with some of these technologies that people have come up with and put in the marketplace largely to address COVID. But here's an example of a tape that's impregnated with silver ion. And silver by itself is a disinfectant. It will kill bacteria, it will kill viruses, it causes the cell walls to rupture and the DNA to no longer be able to produce. So you can wrap door handles or faucet handles with this tape, and it's not instantaneous. It does take a little bit of time, but you have the advantage that every morning you walk in, overnight, this tape has killed any bacteria or viruses that may have accumulated on it over the course of the previous day. So, these are technologies and innovations. They're not very expensive, but they're proving to be very effective. One last thing that it's not new. It's been around, but not many ice companies use it. Is something called ATP, and I think I'm saying this correctly. Adenosine triphosphate. It's a measurement of dirt. All right, but we know that where there's dirt, there's bacteria, and so it's a pretty reliable indicator. But if you were to clean an ice machine and then swab it with ATP, you'd get a numeric count that would tell you in a matter of 15 seconds if that bagging machine is clean or not. Same thing for a wall or floor or any other surface in your ice plant. So it's very fast, so you get great turnaround, and if you've actually done a great job. And I think that these are available from Modern Ice and a lot of other companies now. They're not a requirement, they're just a tool to help give you feedback on how effectively you're doing.
Terrific. Thanks, Chris. Those are some interesting technologies. So I guess my last question for today is how can packaged ice producers position themselves as leaders in sanitation to increase both customer loyalty and justify some price points?
Good question. And, we've all been focused so much more on sanitation in the world of COVID. It's raised the bar, not only for our own operations, but in the minds of the consumer. And I think to the extent that we can communicate to the consumer the efforts that we make towards keeping our facilities clean and sanitized, that can really help the consumer see the difference. I mean, if there is a price premium for packaged ice, why is that the case? We can point that we don't have any human hands touching our product. We use commercial scale equipment and ice makers. We have professional water treatment. We have automated bagging. We have climate controlled production facilities. All of these things go to making ice that is food. You don't see those in the equivalent in the marketplace on some of these self-bagging machines and other kinds of places that are dispensing ice. I mean, after all, you're in a Walmart store and that power goes out and the machine sits for a couple of hours. Is anybody coming in to clean or sanitize that? I don't think so. So, I mean, that's a point of difference, is to try to get them to understand the extraordinary efforts that you take to make sure that it's clean and sanitized from start to finish. I think the other part to that is something that IPIO started a long time ago, and that is a program of independent third-party plant inspections. You know, it's one thing to tout your own horn, but when you can have an organization that's respected as independent come in and assess your performance versus what the GMPs are, you know, that's something that you can show your consumers and your customers as a point of difference. And then it also prepares you in case, you know, the FDA were to come in. And, you know, none of us want to see an FDA inspection. You know, it's not a pleasant experience necessarily. But I think if consumers can understand the idea that we're subject anytime, day or night, to a FDA inspector coming in, and that simply isn't present in a convenience store back room or any of these other places that make ice under less sanitary conditions. So you add that, plus the monthly testing that we do for coliforms and HPC, you know, taking that, I think, is the value equation, helping consumers understand, you know, why our product is significantly better than what they can buy elsewhere.
Terrific. It's very good information, Chris. I think at this point, I'd like to turn and open it up for any questions that any of the participants have today. So if you do have a question, there's a chat box in your lower bottom right portion of your screen. Please feel free to enter a question. Hold on one second. All right. Chris, I see one question here. It says, if I do these things, can I claim my ice is virus-free?
Good question. Unfortunately, I would not want to go there. Saying something is absolute absent is a claim that you know, the FDA can hold you accountable for. What we can say is that we clean and we sanitize, and at the end of the sanitizing, we are largely virus and bacteria free. But you know, we're not sterile. This is not a hospital operating room, so we want to be careful about how we position our claims.
Okay. Another question here is, how do you know when equipment and sanitation is done properly?
Yeah. And, you know, I think this is something, we don't have to overcomplicate this. I think that the people in this industry have a very good idea. Visually, they can tell when that equipment's clean. They know where to look. They know the places that can harbor bacteria and viruses. So I would trust your judgment. And then, you know, if you wanted just to validate, you know, that you're seeing the right things, that's where something like ATP can come in. It's also pretty easy to do swabs of pieces of equipment. And you can incubate it the same way you do HPC. Your local lab can help you there. The only problem with some of these techniques, other than ATP, is they may take a couple of days before you hear back. But trust your judgment, trust your gut, and if you're doing it properly, and that's why I come back to, for instance, are you making sure that you're using the right concentration of a sanitizer? Because using chlorine at 50 parts per million is a whole together different story than using it at 200 parts. Or if you're using quats 200 versus 400, they have different efficacy, and you don't want to leave that to somebody's judgment, you know, of seeing, you know, does it smell right or something. Use those test strips, and that can help give you confidence that when you see that equipment looks clean, it is in fact clean.
And these test strips, they're kind of like what you'd use to look at a pool.
Yeah,
you just
exactly.
And read a color.
Very inexpensive. And, you know, they're very accurate.
Terrific. Here's another question for us, Chris. How frequently should I sanitize my equipment, building, and rooms?
Okay. Well, as all of you know that have been through this preventive controls, this needs to be based on a risk assessment. So every plant is different. Every piece of equipment is different. So I can't give you a blanket rule of thumb to clean everything on the same frequency. But I can tell you that places like the bagging room should be cleaned every single day. And bagging equipment should certainly be washed down every single day. Focusing on where we wash our hands, keeping those areas clean. Any kind of things that are related to employee hygiene should be kept as clean as possible, and that generally means a daily frequency. And then it's up to you to make the judgment call. I know some plants look at their auger systems or their rake bins on a quarterly or semi-annual, or maybe they only feel they need to do it once a year. It's a good idea, though, to be able to explain to an inspector how you came to your decision on the frequency. And again, there is no mandated frequency. There's no rule that the FDA says I shall do it on every so many days. About the only hard and fast rule we have is part of the PICS program that says if an ice maker sits idle for 5 or more days, then it should be cleaned and sanitized. But other than that, it's pretty much up to you. Ultimately, the responsibility is yours. The buck stops with you. So there's always a judgment and a balance between how much you can afford to do, how much you have time to do, based on the need that you've got for it.
And based on your assessment of the risk.
Yes. Yeah.
Correct. All right. Another question here is, where can I find a shoe cleaner?
Well, I think I sent you the supplier. They're available over the internet. It's not terribly complicated. It's a rubber mat that has kind of like knobbly knobs on it. You literally just pour 1 to 2 gallons of Quats in it at the beginning of the week. The idea is not to submerge the shoes. People won't do that. What you're trying to do is just coat the bottom of the shoes as people walk in and out of an important area. These things will last for 6 months to a year, and then you pour the Quats down the drain and start it fresh the next week. It's better to use Quats because the chlorine can break down the rubber or the plastic in the mat faster.
Okay. Let's see. A couple more questions. Can I sanitize my rake room with ozone gas with it full of ice? And does that pass FDA test?
Good question. There are food manufacturers that use ozone for large space cleaning. The device you saw earlier has the capability of not only putting ozone into the water, but literally putting it into the air. If you do that, you want to be careful on 2 fronts. One is that high concentrations of ozone gas can eat plastic. I mean, it literally will eat rubber. Not the normal levels, but if you're putting it up high enough and saturating a room where you want that ozone gas to be effective, you want to make sure of your building materials. The other thing is you don't want people anywhere near it. So when we use ozone gas generators, which I tell people, if you've ever been into a hotel room and somebody smoked and they charge you to clean it, what they're doing is putting an ozone machine in that room and turning it on for 3 or 4 hours, leaving that room unattended, letting the machine turn off and the gas dissipate. So if you came in and you started it on a Friday night, by Monday morning, you wouldn't have to worry, but you would not want employees in that space where you're using ozone gas. In terms of FDA tests, at the end of the day, what the FDA will tell you is they don't really care how you do it. They're only interested in the results. So they're going to ask you, how do you know that your surfaces are clean? And if you've used ozone gas and you've gone in and done swabs and they come back clean, that's the evidence that they'll want to see. But just using ozone or really using any sanitizer or anything else, that doesn't give you the free ticket. It's, was it effective in reducing the bacteria and the viruses?
Terrific. Does an ozone generator running overnight sanitize the bagging room?
Again, a follow-up to that previous question.
Yes.
I'd want to talk to somebody like your company to make sure that that bagging room was designed with materials that I didn't cause unintended issues. I think it's partially an engineering question. It can certainly help, but don't rely on any single strategy to be 100% effective. It may be using something like an ozone generator, maybe on a quarterly basis, maybe even sharing it between a couple of different locations while you're doing your regular sanitation. We also talked about these electrostatic cleaners. That's another tool. It's not the silver bullet, but combining that with just good practical sanitation program is going to help you keep your plant clean and try to do it in an efficient way.
All right, terrific. Well, that is all the time we have today. So thank you all for attending today's Solutions for Critical Sanitation. You will each be receiving an email with a link to the recording of the webinar. And I apologize again for the earlier technical difficulties, but you'll get a recording of the webinar that you can re-listen to, along with some of the additional information about what we discussed today. Thank you again very much. And here finally, contact information. If you have any additional questions and would like to reach out to either myself or Chris, there are the contact information for both of us that are available on this webinar.